Hello everyone. Let me start with a simple thought. Whenever you use a mirror, whether in your bathroom or in a car, have you noticed that over time the reflection becomes dull or faint? That's because the mirror coating starts to deteriorate. But what if I told you that in advanced optical instruments like periscopes, binoculars, or cameras, scientists don't use ordinary plain mirrors at all? Instead, they rely on a clever piece of physics called a total reflecting prism. Unlike a mirror, this prism reflects the entire beam of light without any energy loss. The result? Images that are brighter, sharper, and much more reliable. Let's dive into how this works. Before we understand why prisms are better, let's quickly recall the principle behind them: total internal reflection. This happens when light travels from a denser medium, like glass, into a rarer medium, like air, and the angle of incidence inside the glass is greater than a special value called the critical angle. According to Snell's law, n1 sin I equals n2 sin r. When I becomes greater than the critical angle, the refracted rate disappears and the light is completely reflected back into the denser medium. In other words, 100% of the light is reflected, no leakage, no absorption. And this is the powerful idea that prisms exploit. Now, let's see where these prisms show up in real life. In a periscope, which is often used in submarines, prisms are arranged so that light from the object is deviated by 90 degrees, allowing us to see above obstacles. In binoculars, pairs of prisms turn the image around by 180 degrees so that the final picture we see is bright, and magnified. And even in cameras, prisms are used to bend light paths in precise directions while keeping the image quality intact. So, whenever you're enjoying a clear view through binoculars or capturing a sharp photo, remember, it's not just lenses, but also prisms making it possible. So, the big question is, why choose prisms over mirrors? Well, a prism using total internal reflection reflects 100% of the incident light, while an ordinary mirror reflects only about 90 to 95%. Mirrors require silvering or an aluminium coating at the back, and with time, that coating deteriorates, making images faint. But prisms? They never lose their reflecting power. Another important point, the energy of the reflected ray in a prism is exactly equal to that of the incident ray, so there is no loss of brightness. This is why the images from prisms remain sharp and clear year after year. Let's put this side by side. In total internal reflection, light must travel from a denser to a rarer medium and the angle of incidence must exceed the critical angle. In contrast, reflection from a plane mirror can take place at any angle and from any medium. In TIR, the entire incident ray is reflected. In a mirror, only a part of it is reflected while the rest is absorbed. Most importantly, in TIR there is no energy loss, the reflected ray is just as bright as the incident ray. But in a mirror, there is always some loss, and that's why reflected images are less intense. So, prisms provide perfect reflection, whereas mirrors give you only a compromised version. Let's solve a quick example to see this principle in action. Suppose we have a glass prism with angles 45 degrees, 90 degrees, and 45 degrees. Its refractive index is 1.5. A light ray enters the prism normally on one face. Will total internal reflection occur at the second face? Step 1. We find the critical angle. Using the formula sin C equals 1 divided by refractive index, we get sin C equals 1 over 1.5, that is 0.667. This gives C equal to about 41.8 degrees. Step 2. Inside the prism, the light falls on the second face at an incidence angle of 45 degrees. Step 3. We compare Since 45 degrees is greater than 41.8 degrees, the condition for total internal reflection is satisfied. Therefore, the ray undergoes total internal reflection and is deviated by 90 degrees without any loss of energy. This is the beauty of using a right-angled prism in instruments. Alright, let's quickly wrap this up. A total reflecting prism makes use of total internal reflection to reflect all of the incident light without any energy loss. This ensures that the images are bright and clear. Unlike plane mirrors, which lose brightness due to absorption and deterioration of the silver coating, prisms remain effective forever. That's why devices like periscopes, binoculars, and cameras rely on prisms instead of ordinary mirrors. So next time you look through a pair of binoculars or use a camera, you'll know the hidden secret. It's not just lenses at work, but also prisms using the magic of total internal reflection. I hope this clears up why prisms are preferred over plane mirrors in advanced optics. See you in the next session with yet another fascinating concept of physics.